Okay, you may not like this example quite as much. So we have a cube or cuboid, no cube, sorry, and we want to prove the diagonals OE and BG bisect each other. So we've got a diagonal going from O to E, diagonal going from B to G, and we want to show that they intersect and split each other in half. So we're going to let H be the intersection of OE and BG. And then the trick with these questions, I know we did them in 2D, but this is just a 3D example, is to get to H in two different ways. So I want to go along this diagonal OE. So OH is going to be a little way along OE. We want to actually prove that R is a half, and then it's bisected. And OH is also, so we need to come at it from this diagonal BG. So it's also OB plus going along BG by an amount S, and we want to prove that S is a half as well. From these, we've got two different ways of going along OH. So R OE is equal to OB plus S BG. And then I've been given these vectors here to work with. So going from O to E is going along here, so that's A plus C plus B. So I'm just following these vectors. So O to E is A plus B plus C. So A plus B plus C if you go that way through. OB is vector B, position vector for B, and then it's S, lots of B to G. So to get from B to G, I can do A minus B plus C. And then if you compare left with right, so we're going to compare coefficients. So that's the number in front of. On the left-hand side, I've got R lots of the vector A. And on the right-hand side, I've got S lots of the vector A. So R is equal to S. Doing the same for B. On the left-hand side, I've got R lots of B. Here I've got 1 lot of B, and here I've got minus S lots of B. And for C, I've got R lots of C is equal to S lots of C. So these equations are the same, so they're not going to, this one isn't going to actually add any more into this. Adding these two together, you get 2R is equal to 1, which implies that R is a half, and if R is a half, then S is a half, and that also fits that one there. So they do intersect. And so OH equals a half OE, and BH is equal to a half BG, so diagonals bisect each other. So I wanted to show you that one just to remind you partly about just travelling along A, B's and C's to get to different points. And also, if you do get one like this, you just need to find, okay, I want to go along this diagonal, I also want to go along this diagonal, find two different ways of expressing OH along the diagonals, and then work through from there.